Hello, everybody. Mr. Rubo here. Today we're going to go through a few pages in the notes packet. So we're going to start with 1-10. We're going to skip number 5. If you want to try it, feel free. But we're going to go to number 6 here. All right, so we have, is it possible for a triangle to have a perimeter of 4 if the ratio of the side lengths is 10 to 11 to 12? So whenever you have a ratio, especially a 3 or more ratio, what you want to do is you want to set up an equation where um, each of the ratio numbers you are putting it with x. So it's 10x, 11x, 12x. Because we're talking perimeter here, we would add them together. That should be a plus sign. And we are saying, is it possible for them to have a perimeter of 4? So what we're going to end up doing here, solving for x, getting that answer, and then substituting it back in for each of these lengths and see if that those lengths would make sense for a triangle. So let's go ahead and add these together. So that's 33x equals 4. So x equals 4 over 33. Okay. So again, there you have the ratio or the x value. And so now if you plug them in to each of those, when you do 10, you get 40 over 33. When you do 11, you'll end up getting 4 over 3 when you simplify that fraction. And then for 12, you'll get 16 over 11. Those are all lengths. They're all positive lengths. And we actually know a triangle will be formed because of the triangle inequality theorem without even doing necessarily doing it all, because we can also use the 10, 11, and 12 to do it. So I do know 10 plus 11 is bigger than 12. You could check it here as well. 40 over 33 plus 4/3 is going to be bigger than 16 over 11. So this is a yes. Okay. So then if we're doing the next one, still 4. So in this case, is it possible for the ratio of the side lengths to be 1, 1, and 1? Well, it would be x plus x plus x equals 4. So it ends up x is 4/3. And that means they're all 4/3. And 4/3 plus 4/3 is bigger than 4/3, which means a triangle is indeed formed. This would be an equilateral triangle because all the sides are the same. All right, so now, is it possible for the ratio of this triangle of the side lengths to be 1 to 1 to 2? So here we'll kind of see what happens. There we go. And so you end up, you get 4x equals 4, so x equals 1. And you get that it is, these are the side lengths, 1, 1, and 2. But 1 plus 1 is not bigger than 2. So this is no triangle formed. Okay. So, that's the thing to check here. And I will also tell you that, we did need to figure out what the each side length was, because it could have been, there may have been a possibility it was negative, but then also as far as the triangle inequality goes, you can always just use the ratio to see. You don't have to use the new values if you know the ratio. All right. Cool. So then going on to page 11. So for this one, we're not going to do all of it together, or I'm not going to do all of it in the video. Any ones I don't do, I would recommend you trying on your own. Make sure you understand how to do them. But this should be reviewed. This is solving systems, linear systems specifically. And we're going to go over the two main methods that you'll use, which are substitution and elimination. So substitution, remember, is you have to solve at least one of the equations for one variable. You can solve it for x, you can solve it for y, it doesn't matter. But then you're going to take whatever that variable equals and substitute it in to the other equation for that variable. So in this case, I have negative x plus 5 equals 2x plus 11. And now we solve. So 3x equals what? Negative 6. X equals negative 2. And then once you have that, then you take that x value, or again, whatever number you, whichever variable you solve for, and you go ahead and substitute it in to one of the two original equations. It does not matter which one, so I would always substitute it into the easier one, which I think is the second one. So here, two negatives make it positive, so we get 2 plus 5, which is 7. And usually we will write our answer for a two variable system as an ordered pair. So negative 2 comma 7 is my answer. Okay. So yeah, substitution, great option, especially if one equation is already solved for a variable, or like in number 2 where you can easily subtract something and now we're solved for a variable, right? So you can see here I subtracted that 4x, and now I would take this, substitute it in for the y over here, and then finish that off. So again, if you want to try those 3 problems, feel free. They're good practice. So now let's go to elimination. So elimination is named what it is because you want to try to eliminate variables. So the first thing you should always try to do is manipulate the equations so that your x variables line up, your y variables line up, and then your constant terms line up. And by line up, I mean like they're on the same side of the equal sign, they're in the same order. So you can see in number 5, we have that. It's 5x minus 4y equals negative 3, then negative 3x plus 4y equals 5. Okay. Then what you want to try to do is have one of those variables coefficients be opposite numbers. Okay, because if they're opposites, what you can then do is add the two equations together. So 5x plus negative 3x, well, that's 2x. Negative 4y plus 4y, well, that cancels. It eliminates. That's why we call it that. And then negative 3 plus 5 is 2. So then just like substitution, we finish and solve for this one variable. And then once you have this variable, you substitute it back in to either one of the equations. Again, I'm going to choose the second one just because I see that I'm going to be adding this over, so it makes it not too bad, right? So 3 plus 5 is 8, divided by 4, so you get y is 2. So my answer is 1, 2. Okay. Now, if you have it where there is no opposites to begin with, you can do multiplication to one or both of the equations as needed. You also will want to move stuff around if they're not set up the same way. Usually we go for standard form, but technically it doesn't have to be as long as your variables are on the same side of the equation and lined up. So just kind of real quick looking at number 6, we have x, 2x, 3, and 3y and y. So I could choose, I could multiply the top equation by negative 2. I could multiply the bottom equation by negative 3. Either way, that would cancel out one of our variables. So I'll just do the first one I said, so negative 2. So I get negative 2x minus 6y equals negative 12. And now I can add straight down. So the 2x and the negative 2x cancel. This becomes negative 5y equals negative 20. So y equals 4. And again, just go right into either of the two equations. Again, am I going to do the second equation? It's not always the second equation. Or you could always use the second equation, but I would choose whichever one's easier. It just so happens it's been the second equation every time. So we get 2x equals, that's a negative. So that's negative 12. And x equals -6. So our answer is -6, 4. Make sure you pay attention to which one's your x, which one's your y, because this is an ordered pair. So if you put it the wrong way, it is wrong. All right. So yeah, 7 and 8, try those. 8 may look hard, but you still follow the same rules. You want, if it's a fraction looking thing, you just multiply to get one of the fractions the same. So what I would probably do is I would move the 2y over and then multiply everything by 2. The reason 2 is because that'll get those to be 4. Multiply the first equation by 2, I should say. So yeah, you'll get 4 over y, and it'll be minus because you'll subtracted it over. So yeah, go ahead and try those if you want, and then we're going to keep going with this video, though. And remember, you can always pause the video and try out those problems if you'd like. So take your time and try some practice. All right, so on 12, we have a couple things here. So we are trying to find angle CBD. So this angle right here. And we have two variables, right? So we have the x, but then we also have the y in CBD. So this is kind of one of those situations where I need to set up a system of equations. And there's two things we know, or we should know, that all of the angles in a triangle add up to 180. So I can say this, right? X plus 2x plus 3y plus 63 equals 180. I'm going to simplify this just for the sake of not having to do it later. And what is that? 17. So yeah, there's that one. And then the other equation we can come up with, because since we have two variables, we need two equations. The other one is dealing with this. Well, they form a straight line, which means those two also add up. Those two angles also add up to 180. So I just take the two angles, say it equals 180, and now again I want to put this in standard form. So we get that and 183. All right, so now I'm going to line these two equations up just so it's easier to do my math. And I'm also going to, so there we go. I'm going to do something a little different. So this is set up nicely for elimination because we have the two variables and they have the same coefficient. Now, on the last page, I said, try to make them opposites. But if they are the exact same, instead of adding, you can subtract. The one thing you want to be careful with subtraction is you are subtracting the entire equation. So make sure you don't accidentally, what's it called? Add something. Okay. So here, 3x minus 6x. I probably should have done it the other way, but it's okay. I'm going to deal with some negatives here. So I get 3x, the 3y's cancel, and then 183 minus 117 will be 66. So I get negative 66. And in this case, I'll get x is 22. Well, I need x and I need y, so I'm going to go ahead and substitute this in to this equation. All right, and when you solve this, you get 66, so subtract that over, divide by 3, and your y value will be actually, you could do it that way to find your two y values, but I don't need to do this, actually. I'm going to, if you did this way, that's fine. You can totally do it that way. But the other way you could have done it is because we can figure out what this angle is. So 4 times 22 minus 3. So that's 88 minus 3, so 85. And then because we know this is a straight line, 180 minus 85 is 95. And that's the angle we're looking for. So that actually saves us a step from having to solve for y. But if you did solve for y, like I was going to do, you then can plug in x and y into this equation, or into that expression, and you would get 95 as well. So either way works. But if you kind of notice those things, it'll save you a few steps. All right. So here's kind of a very similar situation. So I'll kind of let you guys try this one out. But I will tell you the two equations that you are setting up are angles 1 and 2 added together equal 180, and then angles 2 and 3 added together equals 180. Technically, there is one other thing you could do, but we haven't proven it yet, so I don't want you to get too ahead of yourself. Okay. So that'll be your equation. Try it out and check your answers on Canvas. All right. So now let's keep going. All right. So this is going to be the last instructional thing of this video, which is introductions, an introduction to proofs. So with this, what a proof is step-by-step statements and reasons that will prove something is true, okay, based on given information, okay? So the way we set this up, there's a few different ways of proving. The one we're going to use the most in this class is a two-column proof, which has statements. Oh, that didn't, my pen went crazy there. Statements and reasons. Okay. Now, your statements will be specific to the problem. Your reasons are not specific. They are general reasons. Okay. And you'll kind of see what I mean as we do this. So usually I'll just put S and R, but for this first one, I'm going to write statements and reasons. So your first thing, pretty much always in any proof, you're going to start with your given. Okay. Now, you do not have to put all of your given at the beginning. A lot of times I recommend just putting the given as you need it. So here we have measure of angle CAB equals 140, and my reason is it was given. So you just write given. And I will also kind of put this out here. Okay, so that's 140. Then my second statement is the other given. BAE is 40. So 2, that is also given. And also I'm going to put it up here. Technically this order you can do in any order. Okay. And I guess the other thing you always want to keep in mind when you're doing a proof is what you're trying to prove. So they say we are trying to prove that angle CAD and BAE are congruent. Congruent again means the same size. So in this case, we want to show that CAD is 40 degrees. Now, what we're going to do is we're going to take this one step at a time because that is how proofs work. So what you're going to say is for the first thing that's not the given is that angle BAD is a straight angle. Okay. And our reason is it's assumed from the diagram. If you recall from yesterday, really the only things we can assume are straight lines or straight angles. So we can do that assumption in our proof. And I will tell you a lot of times, or as you get better with proofs, I won't require this step. Okay, you usually can skip this. All right, so then our next thing is that angle BAD, measure of, is going to equal 180 degrees. And then here's where the real reasons start coming in, which most of the time our reasons will be in the format of if-then statements. So our if is usually the previous statement or one of the previous statements. So if an angle is straight or is a straight angle, then the measure, or actually I should say its measure is 180 degrees. And so you can see here the if, again, is something that I've already said in a statement, and I've already given a reason why it's true. And the then is the statement we're saying, well, it's 180 degrees, okay? So now, because we know the BAD is 180, and then we also know that, CAB is 140, we now know that measure of angle CAD, which is the one we want, is 40. And the reason for this one you could try to write in an if then, but because we're just doing a basic operation, we just write what that basic operation is, which we are doing subtraction. Technically it's angle subtraction because we're subtracting angles, but we can just write the word subtraction, and then I will write the actual subtraction in parentheses next to it. All right, and then our final step, our final statement is what we were trying to prove, which is that angle CAD is congruent to angle BAE. And now we have to have a reason for this. Well, the reason is if two angles have the same measure, so if two angles have the same measure, so you look back and you see that's an angle with the same measure, and that's an angle with the same measure. So there's the before part. Then the angles are congruent. And that is exactly what we were trying to prove. And yeah, there's your first proof of honors geometry. Okay, we will be doing a lot of these this semester, so get used to them. But again, most of your reasons should be in the if-then format. All right, so then the last thing for today is this warm-up page. It's all just review of stuff we've done. So go ahead and give that a try. The answers are on Canvas, so take a look at those once you're done, and have a good day.